Hey, grade 12. So we've just gone through this page, which is all about the first derivative. Okay, remember this first principles gave us the formula, right? In this case, 2x, which is then used when you sub something in there to give the gradient at a point on a function, right? Or to give the gradient of the tangent to that graph at a point. Okay, this first principle is very important. You're always going to be asked to do one or two of these. Okay, so I just want to also talk to the note that you were issued out on Friday. Alternative notations or different ways to write first derivative. Thus far, we have used the f prime or the f dash, whatever notation for derivatives. The following alternatives are also used. If fx is 5x squared, determine the first derivative. If y is equal to 5x squared, determine dy over dx still means the first derivative. If y is equal to 5x squared, determine y dash the first derivative. Determine the derivative with respect to x of 5x squared. There we go. Another way to write it, determine dx, which also says the derivative with respect to x of 5x squared. Okay, so you could be asked various notations which all mean the first derivative. Okay, just before we go on to this summary, I just want to talk about the exercise we did in the last video, in your last few days. Here you've got your function, and there is the first derivative of the function, right? So in 1.1.1, a few days ago, you had the graph fx is equal to x. And we worked out that through the first principles that the first derivative was 1. 1.1.2, you had the graph 1 over x, which can also be written as x to the power negative 1. And your first derivative was negative x to the negative 2. 1.1.3, your graph was 1, your first derivative was 0. 1.4.1, you had 5x squared, your first derivative was 10x. You had negative 3x squared plus x, your answer for first derivative was negative 6x plus 1. And your 1.5.1 was x cubed, your answer was 3x squared. I think there was one more, it was fx is equal to, I think this was 1.5.2. Negative 2x cubed, was that the question? Yes. And your first derivative we worked out was negative 6x squared. Okay, just a summary. I'm going to get to why I'm talking about that in a bit. Here it summarizes it for you. From the previous exercise, as I had on my page now, the derivative of x to the negative 1 is negative x to the power negative 2. The derivative of a constant is always 0. These are just the rules of how first derivatives work. The derivative of just x will be 1. The derivative of x squared is 2x. We had a similar one in our exercise. The derivative of x cubed is 3x squared. Now there is a rule that's popping up here, which is very important to use, and it's the shortcut method here. Okay, if this pattern is continued, complete. These are from your worksheet, from your notes on Friday. The derivative of x to the 4, what would it be? It would be 4x cubed. The derivative of x to the n, what would it be? N times x to the n minus 1. Okay, so from looking at the last page or two, the long way to work out the first derivative is the first principles method, right? You need to know this. The shortcut method is this formula. The derivative of x to the power n is equal to n times x to the power n minus 1. In other words, this exponent over there gets multiplied at the front, and you reduce the exponent by 1. That's it. Okay? So let's just thumb suck some questions here. You are going to go to the exercise and practice it, but just for some examples, just to make sure you know what I am talking about here. Here are, let's just do a few. 5. What's 1, 2, 3, 4, 5? Fx is equal to x plus 2. What will the first derivative be? Remember, there is a 1 up top there. So when I apply my formula, my shortcut formula there, it says that the exponent comes to the front, 1, x, but now if I reduce the 1 by 1, I'm going to go to naught. What is x to the power naught then? Naught. X to the power naught, sorry, is 1. So you are going to have, I'm going to go slowly here, x to the power naught. And what is the derivative of a constant? It is 0. So that will make 1 times 1, our answer 1. Okay? Let's try another one. How about if our derivative, our function is, let's say, 5x squared plus 3, right? The first derivative will be what? The 2 up top must be multiplied in the front, so 5 will be multiplied by the 2 to give us 10. X to the power what now? 2 must be reduced by 1, remember? So, to the power 1. What is the derivative of a constant? Nothing. It's 0. So there is my answer for the first derivative of this function. Let's do another one. How about if I say 2x cubed plus 2x? What will the first derivative be of this function? Let's use our shortcut. The 3 will have to be multiplied by the 2 to give us 6x, and then my 3 is reduced by 1 to give me 2. Here, I've got an exponent of 1 there, so 2 times this 1 gives me plus 2, but if I reduce my 1, I get 0, and x to the power naught is 1, so therefore I have just simply a plus 2. That is then the first derivative of my function. We can now complicate it and give us a 1 over x plus root x. Oh, okay, I'll need a few lines for this. Okay, watch carefully. You can't apply the shortcut when there are fractions or roots. We first have to get it out of those formats. So I can first say that fx is equal to, how do I get that to the x out from the bottom? It would be x to the power negative 1. Do you agree? How do I get the x out of the square root? It would be x to the power a half. Do you remember? Now I'm ready to apply my shortcut. So the first derivative of this function, let's take the negative 1 and times it to the front. So I'm going to have negative 1x. Then I have to reduce the negative 1 by 1. I'm going to get to negative 2. Now let's focus on the next term. The half must be times by the 1 in the front there to give me plus a half x. And my half must be reduced by 1. What is a half minus 1? Negative a half. That is the first derivative of that function. Okay? Remember, the long way would be to use the first principles, but this is way quicker and way easier than going 6, 7 lines. Okay, so just to conclude here, there are some rules for differentiation, and I actually used a few of them when I did those few questions. The derivative of one function plus another function. Okay, so for example, when I said 5x squared plus 3, 5x squared plus 3, right? You'd have to derive the fx and derive the gx. So you derive each term on its own. The derivative of k times fx, so 2x squared, let's say, would be the same as saying 2 times the derivative of fx. Okay, so simply leave the 2, the constant, out in the front and multiply it by the derivative of that function. Then, this is the formula here we've been dealing with. The derivative of x to the power n will be n times x to the power n minus 1. Okay, here's a little example. The derivative of that whole expression means the derivative of 5 times the derivative of x cubed minus 10 times the derivative of x squared plus 4 times the derivative of x plus the derivative of 1. You need not show your working out like that. That's a bit confusing. Watch here though, if I just use my shortcut method. 3 times 5 is 15, x. 3 must be reduced by 1 to give me 2. Okay? Minus 2 must be times by the 10 to give me 20, x. The 2 must be reduced by 1 to give me 1. I don't have to write the 1 there. Plus, there's a 1 over there. The 1 times the 4 is 4. If I reduce that 1 by 1, I get 0. And x to the power 0 would be 1. So simply plus 4 is left. And lastly, the derivative of 1 is 0. The derivative of a constant is always 0. And there is my first derivative. There is the same answer over there. Okay. In differentiating an expression using only the above laws, follow the following steps. Firstly, transform the expression into a polynomial in which each term is a power of the variable. In other words, get rid of what? Roots. Right? You can't have roots with an x in a root sign. You can't have x in the denominator of a fraction, right? And you can't have brackets, right? You're going to have to FOIL first before you apply our shortcut. So there's a little tip there before you do your derivative and work out your steps. So here's an example. To differentiate y is equal to 5x brackets x minus 4, you first have to transform it to, times it in, 5x squared minus 20x. Now we can say, then the derivative, remember I could also just say y dash equals 5 times the 2 is 10, reduce the 2 by 1, I get 1. Minus 20x is simply minus 20, my x falls away. Happy. So there's my first derivative to this function. Okay, so I hope that these rules, as well as this very important shortcut, where you just times by the front and you reduce it by 1, in other words, this formula there is going to assist you going forward. The next exercise you've got to do is work through this exercise here that goes from 1.1 all the way, I think it goes over to 1.20. Okay, so make it a polynomial and then apply the shortcut method. Okay, good luck, gents. Please shout if you have any questions.